Hey friends, so in this video I want to walk you through the process and the mindset you need to refactor code. Now I'll be using Go code here for my example, however the concepts and the ideas should apply to other languages. What is refactoring in the first place? By definition, it's the process of restructuring existing code without changing any external behavior. There are some exceptions, but this is the general definition of it. Now, why should you even consider refactoring in the first place? I think you should refactor if you're trying to reduce technical debt or if you want to make your code more readable, maintainable, and extensible. And so when should you consider refactoring? I think you should consider it whenever you're adding new features, fixing bugs, and most importantly, whenever your team is aware of the time investment you're about to make. It's important to note that refactoring code does not add any value to your end user. It's only improving your code. There are some pitfalls to keep in mind whenever you try to refactor. Number one, if you're refactoring without any tests. Number two, if you're refactoring without any clear goals. Number three, if you're refactoring too much at once. And number four, if you're refactoring too late. Now we can start working through our example. And before we do so, we have to make a couple assumptions. So we're assuming that this code is part of a larger code base. I'm also assuming that we have enough tests for most of the code written, and we are not using any test-driven development or any other concept like that. So here's our example. We have a process order function that is supposed to process customer orders. We pass in a bunch of parameters. Then we validate all our inputs. We do some calculations, apply a discount, calculate the shipping cost, calculate the taxes and the total. Then we attempt to save the result in a database and send a confirmation email. Now, the rest of the code you see here, this is just kind of dummy code that I'm using to kind of support this function up here. So this get database here, you see it's empty. The whole point is to kind of have the code be functional. Okay, so let's analyze our code and see what we can find. First, I'm going to look at the function definition. The first problem I'm seeing is that we're just passing too many parameters here. We have 7 different parameters, and that is a lot of parameters. Second, we have items, quantities, and prices, and these are all related. However, they're being passed as separate arrays. I think there's a better way if we can just combine them and just pass in the original structure. Now, if we look at the body of this function, notice that it's validating the input, doing calculations, interacting with the database, and even sending emails. That to me feels like so many responsibilities for a single function. If you look at the discount logic, shipping cost, and the tax rates, all these things are being hard-coded, and these are essentially business rules. Everything is being hard-coded here, and that's another red flag for us. Another problem I'm seeing here is that we're interacting with the database and the email service directly. So we're talking to an external dependency directly within this code, which makes it difficult to test because we cannot really mock this code. And the last problem I'm seeing is this code is hard to extend. So if you notice all these hard-coded rules here, if we have new ones, we really have to come back to this function and just add things here manually, or even like when it comes to the shipping method. If we change the shipping method, we have to come here and just change things manually. This makes the code a bit hard to extend. So why do we even kind of end up with code that looks like this? So here's what I think. If you start your coding with the question, how to implement the logic given, usually this ends up being a procedural thinking or procedural code. Your brain essentially creates a step-by-step solution that we usually translate to code as this one here. If it's like a process order, we're thinking like, okay, we have a process order function, we need to validate, we need to calculate, we need to do the discounts, the shipping, and then save it, send an email. That's exactly how our brain thinks, step-by-step solution, and we just put it as code. Now, if you change the question from how to what is the problem are we trying to solve here, then you kind of shift your brain from thinking procedurally to become more like a declarative thinking. So you're thinking about the problem itself and not the steps to solve it. What this means is now you're thinking about components, relationships, rules, and things of that nature. So it's not like a step-by-step solution, it's more about the different pieces of this problem. All right, so let's go over all these issues and solve them one by one. I already wrote the refactored code here on the right, and I'm going to show you how I kind of move things from the previous code to the new code. Now, ideally, what happens is you start changing code in the original process order here, and then run your tests and make sure everything works, and then keep doing that. However, to make things clear for us, I just wrote the whole code, and I'm going to explain it to you. The first thing we wanted to solve is the idea that we have like 7 different parameters. Also, we have like related items like or related data like items, quantities, and prices. These are related things, right? So what I did is I created 2 structures that represents all this data being passed here. Also, the kind of the related values here. So we have the order item that contains quantity, prices, and name of the product, and then the order structure itself, which contain all the data that we are playing with here. The second issue we're solving with this refactor is this validation logic here. So what I ended up doing is creating a validate function on the order structure, and essentially this here will simply contain whatever kind of validation code we had in the old implementation. And the next part would be the calculation of the subtotal. This is the calculation part as well. We said like this function contains many responsibilities, and so the second one would be the subtotal calculation. This as well I created as a function on the order struct and essentially used the same logic inside of it. And the next part that I worked on is essentially solving for the discount calculation, the shipping cost, and the calculate taxes. Now we said that these things are hard-coded here, and that is a problem. So what I did is I also created some functions on the order struct, and then what I did is I passed a service for each. First, I created services for each. Essentially, it's an interface that has functions that essentially gives us whatever data we wanted, like get discount rate, calculate shipping cost, calculate taxes. And these things are supposed to give us values like the ones you see here, or like 0 or 10 or 0.08 here for the taxes. So as of now, it's an interface. So we pass the interface here, like that, for example, apply discount. We give it an interface, and we assume that the interface has a function that gives us whatever we wanted. And so I did the same for the discount, shipping cost, and taxes. And so now we need to create or essentially implement these services. If we scroll down a little bit, you see I have kind of the implementation for these interfaces. So I have simple discount service, and with that constructor that we pass in whatever hard-coded value that we had in the old implementation. And we have the get discount rate. And now because we have this get discount rate, it means that we are implementing this interface because we have the same function. And I do the same thing essentially for the shipping service and the tax service. Next part would be the database. So for the database, the assumption was that we're kind of interacting with the database directly here, and that's the problem. So when we write our test, we can't really mock this logic. So what I had to do, similar to the other services here, I created a database order repository, and also I created a interface for it. So if I scroll up here, you see we have order repository that has a save function which accepts an order struct, a pointer to an order struct. The implementation for that would simply be essentially this logic here. So we have a save function that is a function on the database order repository. And the same exact logic for the email notification. And why is this useful is now because we can essentially use dependency injection and kind of have a abstraction on top of these things. So we're not directly interacting with these services like databases or email notification service, which could be really a third-party service that you have to make an API call for. Now we have like a layer in between, which allows us to have some sort of abstraction, and we can mock this stuff. So in your test, whenever you want to call the send order confirmation, you could have a mock code that essentially bypass the API call and you just mock it. And after that, what I did is I created an order service which will contain all these things, all these services in one place, created a constructor for it so we can create all these things as well. And finally, I created this process order function, which will essentially look like this one here, but it's like have the new structure. So now we have a new process order that is on the order service that we just created. It accepts an order struct, and we call all the different services inside of it one by one. So now we can validate like this, calculate subtotal, apply discount, and do different calculations that we need. We can interact with database and even send the order confirmation. However, the most important thing here is that all these things are happening in different places. Like we're just calling them here. We don't have any like strict implementation in this function. We're just calling things outside of this process order, right? So order repository.save, we don't have any like database logic here. This is just using a repository that has an implementation somewhere else. And the database itself, like it's not even a direct communication with the database. We have a repository in between. So to show you how this works in like real world scenario, let's say we have this main function. We have to create all the services, obviously. And in this case, for example, we have new simple tax service, new simple discount service, right? And there's a reason why I call it simple, by the way. Then we create the order service. We generate or create the order structure that we want to work with. Then we call our process order and pass in the order. So the idea here is that if we at some point in life want to change this like new discount service here, simple discount service, to some other type of discounts, all we have to do is simply create a new service implementation for the service, essentially just have an implementation that contains a function called get discount rate. We just need to implement the interface that we created, like this one. And this way we can have kind of a separation of concerns, and you have more flexible code. So any type of discount service that you have, as long as it implements the interface, you can simply inject it here and use it. Where in the old code, if we needed like a different type of discount, we had to come here and just change things manually in a way. Like everything is hard coded, so you have to change things directly in the function. That is not a very good way to do it. So I think that this approach allows me to have a more like flexible code. It's easy to test because right now, for example, I can simply test this specific service alone on its own and make sure it works. And I can do the same thing for any other service I created. So yeah, that's how I managed to refactor this. So obviously I did create I did write some tests for this. I have a full-on big test for all of that code. And that's also a very important part. As you can see, everything is still passing. I also, by the way, had tests for the other one. So order test. A key thing here to remember is that, whether you have, the refactored code or not, it's important to have some tests for both. And the other thing is it's important that whatever the functionality used to do before, it should be doing the same exact thing after. Even though you had to like change some code. For example, if you go back to this main.go, the old function here, the way we used to kind of use it, we had to say process order and pass in each one of these things one by one. Yes, we did have to change this here. So I have to create a bunch of services and then a new order service and then create this order struct and then call the function. There's some extra code to kind of be written. But each one of these things can be tested on its own to make sure it works. And then the new order service itself can be tested. The goal is still kind of the same, right? So whether we call it this way or this way, we're still in a way doing the same exact thing, validating, calculating, saving things in database and sending an email. This basically means that whatever input we gave to this black box, it gave us the same exact output. And that's the whole goal of this refactor for me. All right, and that's everything I wanted to share in this video. I hope you found some value in it, and I'll see you in the next one.